Hello everyone, my name is Samuel Benaya Batubara with the NIM number 22055310997. And this presentation video, I will explain about ferrous metal and alloys, production, general properties, and applications. Ferrous metals, they are iron-based alloys. It is widely used due to their low cost, good availability, and improved mechanical and chemical properties. The main categories are carbon and alloy steels, stainless steels, tool and die steels, and cast iron and cast steels. They have uh, various applications such as sheet steel for automobiles and other appliances, plates for boiler, ship and bridge, structural members like I-beams, rails and crankshaft, tools, dies and molds, and rods and wires for bolts, rivets, and staples. For examples, one car it contains 1200 kilograms of steel, which made up to 60% of its total weight. The production of iron and steel it uses three main raw materials. It is iron ores, coke, which contain obtained from coal, and the limestones. It removes impurities and forms slag. And all these are essential for blast furnace application. So on the figure, this is the schematic illustration of a blast furnace. It is a very tall steel structure, and it is charged with ore, coke, and limestone. So the charged mixture of ore, coke, and limestone is dumped at the top, and the preheated air above about 1100 degrees Celsius is blown into the furnace through two areas. Inside, the coke reacts with oxygen to form carbon monoxide, which reduces the iron ore into molten iron. The product at this stage is called pig iron. It contains about 4% of carbon and some impurities. Steelmaking is refining pig iron into steel. There are several types of method. There are open heart furnace, is older method, but now it's replaced. Electric furnace, it uses electric arc on it or induction, like in the figure below. It produces high quality steels. Basic oxygen furnace or BOF is the most common method. It is efficient and can produce up to 350 tons. And the last is vacuum furnace. It removes impurities and produces very clean steels. And this is the illustration of the basic oxygen furnace. It has the charging, melting, and the pouring of the molten iron. The casting of ingots is basically pouring molten steel into the molds to make the ingot. There are three types of ingots. The killed steel are fully deoxidized, uniform properties. The semi-killed steel, it's partially deoxidized, has less scraps. And the third is rim steel. It contains low carbon, has a ductile skin, and may defects. But there is a refining process. It improves the quality for some critical and different application of this steel. For the methods of uh, it used modern methods. It's called continuous casting to reduce costs and improve the quality of the ingot. The molten steel it flow into tandis and it is water. The water use water cooled molds, and then the metals solidified with controlled cooling that is pulled by the rollers. The advantage of this method is it uniforms the properties in every part, and it has less porosity and may less defects, and it make a direct rolling possible. So this is the schematic of the continuous casting. Carbon and alloy steel. This is the most common ferrous metal. It has alloying elements like uh, chromium, nickel, molybdenum, vanadium. It is used to improve strength, toughness, machinability, or corrosion resistance. And they may have residual elements that may cause defect, like hydrogen embrittlement. And the carbon and alloy steel use a designation system to help engineers uh, differentiate the types based on the application, like SAE, ASTM, and UNS. There are three types of carbon steels based on the level of the carbon. The first is low carbon steel that has less than 0.3% of carbon. The example is mild steel that is used for bolts, plates, and tubes. The medium carbon steels, it contains from zero point 0.3 up to 0.6% of carbon, are used for making gears, axles, and machinery parts. And the last is high carbon steel, which contain more than 0.6% of carbon, are used for tools, spring, and wires. And then there is a special grades with sulfur and phosphorus are designed to improve machinability. Alloy and HSLA steels. It contain a higher amount of alloying elements, giving them high strength and toughness. High strength low alloy steel or HSLA steels, it combines strength with relatively low weight. They are produced by microalloying and controlled rolling. These steels are used in automobiles, bridges, and ships. Advanced grade include microalloyed steels that save on heat treatment costs, and even nanoalloyed steels under development with extremely fine grade structures. So this figure is the comparisons of advanced high strength steel. You can show the comparison of this on the x-axis is the tensile strength, and on the y-axis is the total elongations. We see on the left the mild steel and interstitially free steels. It have relatively low strength but high ductility. The HSLA, it have higher strength but still have some low ductility. The transformation induced plasticity steel or TRIP steels and the dual phase steels, they both have strength and ductility. And then there is this TWIP steels, are they are impressive with very high ductility and combined with high strength. And then there is martensitic steels. There are they are on the far right here. There are have some high strength, but it has low ductility. So these charts help us understand why advanced high strength steel are chosen in automotive and structural applications. So ultra high strength steel are defined as steel with tensile strength above 700 megapascal. This includes the dual phase, the TRIP, TWIP, complex phase, and martensitic steel. The application are various from automotive and other crashworthy design. Stainless steel is famous for the corrosion resistance properties because they have chromium content on the surface, then must uh, have minimum 10 to 12% of chromium. There are different types of stainless steel. The first is austenitic. It is non-magnetic, has ductility, and excellent corrosion resistance. Ferritic contains high chromium. It is magnetic and has moderate properties. martensitic, it is hardenable and has high strength. And then precipitation hardening or pH, it is strong, ductile, and used in aerospace parts. And the last is duplex. It is the mixing of ferrite and austenite. It has high corrosion resistance. And this is the mechanical properties and different types of application of the stainless steel with the different yield strength and dedicated AC or UNS code. Tool and die steels are essential in shaping and machining materials. They must have wear resistance, impact, and high temperature. High-speed steels it maintains hardness even at elevated temperatures and used for cutting tools. The hot work steels are for forging and extraction. The cold work steels are for stamping and shearing at room temperatures. Shock resisting steels are used where impacts loads are high. Mold steels are used for plastic and rubber processing. These steels enable mass production across industry. So this is the IC code for different types of tools and die steels. And this is the processing and service characteristic of common tool and die steel. It has various types of mechanical properties, and we can see the detail of the hardness, the toughness, and is it wear resistance or not. And this is more table for typical tool and die material for metal working process. It has a large variety with different dedicated code and material. To summarize, the ferrous metal and alloys, it remains the backbone of modern industry. Carbon, alloy, stainless, and tool steels, it serve specific purpose. Continuous casting and refining have improved steel quality and reduced costs. The HSLA and ultra high strength steel improve strength to weight ratio for cars and structures. Stainless steels provide corrosion resistance, while tool steels make manufacturing possible. Together, these materials continue to support innovation in engineering and technology. This is the reference of this presentation from the book Manufacturing, Engineering, and Technology 6th edition. And that is all of this presentation video. Thank you for watching.